My name is Ben Kickert. I'm with SDG Counting at the Wolfram Technology Conference today. I'm presenting on how to use the Wolfram technology stack to work with the Sustainable Development Goals.
Good afternoon. I'm Maureen Baehr, and I figured I'd start right on time because we have lots of good coding for you and don't want to take up too much time. Just wanted to give you a little bit of background of why we're here. About 3 years ago, I've been a Wolfram hobbyist for about 10 years. And about 3 years ago, exactly 3 years ago, I came here to a conference to talk about the Sustainable Development Goals and how I saw the Wolfram stack as being very, very good as a tool to work with the Sustainable Development Goals to move ahead in terms of how people all over the world could integrate their stuff to share data and share information on the goals. At that presentation 3 years ago, I was very optimistic, both about what was going to happen with the Sustainable Development Goals and how fast I could get things done. The first year and a half was about waiting. The Sustainable Development Goals were announced, and then it took another year and a half to get them sort of pinned down. And they're still not pinned down. They're set to evolve. What's happened over those 3 years is three different things. The first is that the Sustainable Development Goals, there's a lot more data out there, both UN data and other data. The data is getting into different shape. Different people are looking from different perspectives. The second thing that's happened is that the Wolfram stack has gotten more powerful in the sense of we're able to do things that we wouldn't have been able to do 3 years ago. And the third thing, and probably the smartest decision I made, is that I have hooked up with two very good data analysts and coders who I can sort of say things to, and they can figure out how to do things. So this is Benji Bernstein, who is one of the people who's working on our team, and Ben Kickert, who is going to take over the rest of the presentation. So thank you. Sorry.
Maureen. As Maureen mentioned, my name is Ben Kickert. I'm actually relatively new to the Wolfram community. Only have about 6 months worth of coding experience. But I have been turned on to what this means and how this can be used when it comes to data analytics. My background is actually with on-the-ground work, data management and assessment. I spent 7 years in Swaziland, Africa, working both with local NGOs as well as some of the national level discussions around how we can track the data. To go a little bit deeper into what the SDGs are, if that's not something that's familiar to you, the SDGs are the global goals. Within the SDGs, you're looking at 244 indicators, 169 targets, and 17 goals. Those then are calculated across 255 geographic areas. Within that, as the UN likes to do, you have numerous groupings and subgroupings. Within that, the UN then likes to disaggregate based on age, gender, population, measurement types. Now, looking at the SDGs, you have a wide range of data quality. Of those 244 indicators, as of this month, only 93 indicators are listed as being fully developed, and everybody agrees on how we're tracking and where the data is coming from. 77 of those have been defined, but are not uniformly coming in from all member nations, and there's still 57 of those that lack an agreed upon collection methodology. So we still have a long way to go when it comes to data quality coming in for the SDGs. For us in our work, looking at the analytics of that, we find that the publicly available data sources are largely found in three broad categories. You have the official UN results, you have the derivative analysis, and then you have some original primary data that's feeding into those two. I'm not going to spend much time here. My approach is to kind of give you a lot of things that you can see, give you the ability to dig in deeper if you want to. If you start with the official UN SDG database, this is just a screenshot of the website. You can see that you can choose from any of the goals, the targets, the indicators. You can pick what geographic area you're interested in selecting data from, and you can look at what years you want. So if you want to know about maternal health rates in Djibouti in 2012, you can structure your data to pull that out. If you look up at the top, you realize that as it is of August, there's well over 1 million observations that we're pulling from. The full data size is 300 megabytes for a CSV. If you look at the derivative analysis, what you find here, is these are companies, these are organizations often funded by the UN that are taking those large data sets and saying we either want to make them more readable, more usable, we want to consolidate, we want to be able to report. Often what they're doing is they're also giving you visualizations. So here you see a quick map of how each country is doing, and then different ways that you can interact with the data. The third source of data we work with is what we're calling original primary source data. So if you take the World Health Organization when it comes to tuberculosis, they're considered the gold standard internationally. And so their data sets are incredibly robust. Where the UN reports on one indicator for TB, the WHO will give you 20 or 30 different indicators. And so that feeds into the UN database. If you want to dig in, you can do that through those types of sources. Now, when it comes to accessing the SDG data, one of the things we have to our advantage is because of the emphasis on the importance of data in international development, there's been a lot of raw data that's been made available to people like you and I. So what I'm going to do is quickly look at 3 of those sources that we talked about so you can kind of see what any of you can go and download and analyze if you want to. This first one is the official, it's a sample set of the official UN SDG data. You see it talks about the goals, targets, indicators. You can see what country it's coming from. You can see how they're measuring it by age, by gender, what the value is. The SDG index, on the other hand, is pulling in a broader data source. Here, they're going to give things like under 5 mortality as a single figure. They're going to give you incidence of tuberculosis as a single figure. And then in TB, you can see that everything is being divided out by different age segregations, looking at things like HIV and TB comorbidity. Now, one of the things we find is that when you're dealing with large and diverse data sets, it's important to not just deal with the flat data, but to also look at how these things are connected relationally. Wolfram is not set up as a database software in kind of its purest form, but we found that there's actually ways that we can take this diverse data set, put them together, and find some of these relational connections. So one of the things we've been working with is something we call relational entity stores. It's kind of a fancy name that we've added to it, but it's nothing different than what you see with most of the entity stores that Wolfram hosts. So if you look at country data, for instance, you pull up the capital city from the country data, it's going to give you an entity that you can then follow and find out information about the capital city. We've done the same thing when we're looking at things like the descriptions of the SDGs, the goals, targets, and indicators. So if you look at the properties, this is an entity store that we've created. If you look at the properties, you see we're pulling in the official UN code, the description, but then we've added a property value for parent goal and parent target. If you look down at the actual properties themselves, you realize that for indicator 2.1.1, we have a parent goal of 2 and a parent target of 2.1. Besides having the nice, pretty squared box around it, it actually does some other things as well. Because we've nested our entities within our properties, now with simply adding a single, one more single line of code to what we're looking at, instead of just looking at the description for an indicator, we can pull the description of its target, its parent target, as well as parent goal. So here we see that indicator 2.1.1 is about undernourishment, which is a part of the global goal to end hunger. You can also do things like pull descriptions for all of the goals that are related to goal 10, or all of the indicators that are for goal 10. One of the things that we've done that has kind of changed the way that we do our data analysis is we've taken these entities that we've created and then incorporated them into otherwise flat data sets. So at the bottom under SDG Relational Data, we've taken this sample and we've incorporated the entities that are related to the descriptions behind them. So now instead of just having the UN data as it gives it to you, now you can tap into Wolfram, you can tap into all of the power of the entity stores. And it's not just your own, you can also do it the same way with country data. So here we know that our first entry in our SDG relational data set is from South Africa. So we've replaced the name South Africa in an otherwise flat CSV with the country data for South Africa that we can then pull from the Wolfram entity store. So the significance of this is just with a few lines of code, and this would work for anything, not just the SDGs, you can take flat data and then connect it to much broader data sets and do multidimensional analysis. Now what I want to do, and I'm not going to get into any of the code, everything in this notebook is fully functional. You can download it from the website, run through the whole thing if you want to. Instead, I want to show you an example of how we've been using the Wolfram technology stack to do some analysis. So we're going to start by looking at some of this SDG relational data set that we just created, where we took a flat CSV, we added our own entity data for descriptions, as well as the country data. So doing something relatively simple, we start with the raw counts for country data. How many countries did I put into my sample set? You see I've got 5, and you can see how many data points I have for each of them. Because it wasn't just countries, but it was actually entities that we incorporated into that, we can then take that information and pull in information from Wolfram to give us more information. So let's look not just at what countries they are, but let's pull the life expectancies for those countries. So now our UN data allows us to easily connect and create a visualization where we now have a color-coded graph of our countries that show you not only who are we reporting on, but how are they doing in life expectancy. You see Swaziland and South Africa, not so great. Our neighbors to the north, they're living a little longer than we are. Now looking at what we put in ourselves, we want to look at the indicators that we're tracking. You can see that I'm taking a selection of about 5 different indicators. You can see how that data is spread out. I only have 7 data points on 3.7.1, but I have a lot of information on 3.3.1. So let's figure out what that's about, because it's just a number in the flat data set. So I see that this one is about HIV infections. How many you have per 100,000? Now let's go back to that relational data set and look at the indicators and country distribution. Let's dig a little bit deeper into HIV. I know from 7 years working in the HIV world that they like to split their data 100 different ways and don't always know how to put it back together. So what we want to do is say, ignore, I don't care how many females in rural settings that are under 17 years of age. That in itself doesn't give me what I need. So just give me the information where I have all the sex data and I have all of the age data. So here we now have a second level data set that's just focusing on all of the information we have for cumulative HIV statistics. If we want to visualize that by year, we actually see that it was only South Africa and Swaziland who's reporting on this, which is relatively common because of the amount of investment in HIV in a country like that. We can now look and see what sort of trends we have across years. Now, trends over years are helpful if you want to visualize that. But at the end of the day, I want to know maybe what the max HIV rate was. Where did Swaziland spike? Or I want to know what is the most recent data that we have. So again, using the built-in Wolfram functions, we can easily pull that from the UN data. If you wanted to look at something rather random, you could also look at something like the mean. You know, what is the average across all of the indicators that you're reporting on? Now, because we're dealing with just a single sample set that's not indicative of the whole, we've definitely got some gaps. But as we mentioned earlier, there are a significant portion of the SDGs that countries don't even know how they're going to be reporting on. So we want to be able to take a look at how that reporting is coming in. So here we get a number for how many countries have reported, or how many times has each country reported on each indicator. And if you look at 3.3.2, the second box, you realize we have very, very consistent data in 3.3.2. But again, I work with this every day, but I don't remember all the numbers. Using our embedded entities, we can pull out the description, not only of that indicator, but also how it fits into the larger targets and goals. Now with TB data, when we're looking at that, TB data doesn't just report a single figure when you're looking at the incidence per 100,000. Instead, they have high bounds, low bounds, and mid bounds. So we want to pull out just those mid bounds. And with that, just like we did with our life expectancy, now we can create a geographic visualization where you see that tuberculosis is quite an issue in Southern Africa. Canada and the US, we're going to do okay. At the end of the day, what makes this linking between your own data, public data, and the Wolfram data so helpful is in a couple lines of code, you can pull out that chart that's actually going to show you not only the TB rate that we got from the UN, but also the life expectancy rate for each country. Looking at that from a global perspective, again using the Wolfram technique of natural language, we can simply ask it, what is the global life expectancy for the entire world? With that, we've got a chart that not only shows us what the TB rate is, which I'm guessing most people don't know the difference between a rate of a 10 and a rate of 100 in terms of is that good or bad, but we can see how that rate corresponds to life expectancy and then show it as a percentage of the overall global life expectancy. So in Switzerland, they have their life expectancy is 114% of the global average, and they only have a TB rate of 7.8. Swaziland, where I'm coming from, is showing 400 and has actually one of the lowest life expectancies in the country at less than 70% of the global average. And these are just examples that we are showing as kind of a one-time through of how we're using our information. The same idea of creating relational data sets with either your own entity stores or Wolfram entities can be used in many ways. Now I'm going to quickly go over this. If this is something you're interested in, you're more than welcome to dig a bit into the code. The original presentation, as we're going through the example, I had the long code written out. But one of the things we wanted to do is actually be able to automate a lot of these processes. So we created a couple defined functions that were specifically set up to help us create these relational data sets. The first one's very easy, simply creates flat data or turns flat data into a data set. We can then take a list and turn it into entities. That can either be your own entities, or because it uses the interpreter function, you can also turn that into, say, company data using that same code. You can then use dataset entity replace. So say you scrape a table from Wikipedia about the top 50 countries or companies in China. You can use this to then replace that flat data with the company data. Also, what you can do is if you don't want to do a replace, which is what I'm showing below, you can append an entity to your existing data set. So here in our SDG index, we had all of the information about Afghanistan. But what I've done is I've actually added the entity Afghanistan as the first column. So again, that allows you to dig deeper and do multi-layer analysis where you're pulling in data not only from the country itself in the Wolfram repository, but also from the information that you're bringing to the table. So to close, if you look at the conclusions that we've come to in doing this work around the SDGs, we really have found that using entities as properties and having that multi-layer aspect really allows you to not only to move away from flat data and into a relational context. We found that the Wolfram environment compared to something like Excel is very powerful for parsing and analyzing complex data that's coming in from multiple sources. And as I said before, we find that relatively easily users can combine this public data with the Wolfram data to create multidimensional analysis. Now, some of the challenges we've run into, the automation of the process does require that your data is relatively clean to begin with. We're fortunate that UN data tends to be a little bit cleaner than some other sources. It's not perfect, but at least they try to be consistent. But we have run into issues in the past. Another thing when you're looking at data storage, management, access, distribution, our team is spread across 4 states. And so trying to coordinate the different findings that we have can be a little bit difficult when you're using some of the cloud-based solutions. So a 300 megabyte CSV is manageable on your computer in Excel, but by the time you convert it into a relational data set and start running your analysis on that, if that becomes a cloud object, we run into some issues with that. Also, we found that the Wolfram interpreter function is not flawless. There's times where we have a few results coming back that aren't linking us to the data that we expect. In terms of opportunities and next steps, one of the things that we want to do is to explore integrating multiple data sources into a single unit. And so here I've shown our sample SDG data and I've shown the SDG index data, and I've shown that we have the TB data. Ideally, we want to be able to package that so it's all one piece that can be easily accepted. The other thing, and we've actually been in conversations this week about it, we want to continue to look at some of what's considered gold standard data sources, and to be able to compare it to what's in the Wolfram repository, to either update and provide that information to others who may find it useful, or also to understand where there's gaps when we are pulling in external data. I'm one of the people that has sat in and listened to Stephen Wolfram's live CEOing Twitch and YouTube sessions. And one of the things they've been talking about that got me excited, sending emails at odd hours of the night, is something they're talking about related to entity extend. I'm speaking simply from what I've heard in the discussions. But at the end of the day, you're looking at being able to append additional properties to existing entities, which for us, we're having a workaround, but that's exactly where we're wanting to go. And also for those of you that were in Stephen's keynote at the beginning of the week, when he popped up his database connection to an SQL that automatically converted everything into an entity store, I almost fell out of my chair, because that was a huge step forward when you look at where local data is, where public data is, and what it means for being able to build these relational connections. I think we have a few minutes for questions. If there's anything from the crowd, we've put our information up on the screen. We'd love to be in touch. Feel free to use our code or reach out to us.